What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through sphere and cones. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learning outcomes for today is to understand the formulas for spheres and cones and when to sub what variables into them. This is also to solve spheres and cone exam questions. So, spheres and cones have given formulas which you'll need to use to either work out the volume or the surface area. They can also be used to form composite shapes, such as an ice cream for a real-life example. In this lesson, we will focus on solving spheres and cone exam questions and understand the formulas. To begin with, let's start with spheres. When you're dealing with spheres, the two formulas you are given are volume equals 4/3 pi r cubed and the surface area, which is 4 pi r squared. If you're given a hemisphere, you can simply use 2/3 pi r cubed for the volume and 3 pi r squared for the surface area, as it's half the curved side plus the bottom circle, which is pi r squared. Now, with cones, you'll be given the formulas of volume equals 1/3 pi r squared times h and the curved surface area of pi r l. There will be times where you might need to work out the vertical height of cones, so you may need to use Pythagoras in some questions, because as you can see, r, h and the slant height of l can make a triangle, as you can see by the diagram here. Once again, it's that time to have a go at some Math Genie exam questions. Have a go, pause the video and unpause when you've done. So, the diagram shows a cone. The height of the cone is 20 centimeters and the base of the cone has a diameter of 16. Work out the volume of the cone and give your answer correct to three significant figures. So first, we're going to use the equation of 1/3 pi r squared times h. If we're going to sub our values in, remember if we've got a diameter of 16, the radius is going to be 8. So we do 1/3 and pi times h squared times 20, because that is the vertical height. And this simply gets us to volume equals 1,340 centimeters cubed, and this is the three significant figures. So our final answer is 1,340. Something you need to know when working with sphere and cones, that they are usually crossover questions between foundation and higher students, so it's important to learn them regardless which paper you sit in. The harder questions are when you have to use them with other shapes. This can be either area or volume. With these questions, you may find variables by using your knowledge of other formulas, just the ones given to you, or Pythagoras, like we said when we're using cones. They can also be on calculator or non-calculator papers, so you must be able to use the calculator and understand if it asks for it in pi, you leave it in that form. If it asks leave it in pi, it's most likely going to be on a non-calculator, so try and not use a calculator if you practice them at home. Here's another exam question for you to have a go. Have a go, pause the video and unpause when you've done. So, the diagram shows a solid shape. The shape is a cone on top of a hemisphere. The height of the cone is 12 centimeters. The base of the cone has a diameter of 10 centimeters, and this is the same as the diameter of the hemisphere. They fit perfectly on top of each other. Work out the total volume of the solid shape. Give your answer in terms of pi. So first, let's work out the volume of the cone, using 1/3 pi r squared times h. Once again, if the diameter is 10, the radius is 5, so we do 1/3 pi times 5 squared times 12, that gets us the volume of 100 pi. Now, let's work out the volume of our hemisphere. We know the volume of a sphere is 4/3 pi r cubed. The volume of a hemisphere is 2/3 pi r cubed. And we sub everything in. We do 2/3 pi times 5 cubed, and we get 250 divided by 3 pi. Now, we need to work out our total volume, so we do 250 over 3 pi plus 100 pi, and 100 pi can be written as 300 divided by 3 pi. So we get 550 over 3 pi, and that is our final answer. Now it's time to have a go at some of the hardest exam questions you'll probably be asked as sphere and cones. Have a go, pause the video and unpause when you've done. So, the diagram shows a solid cone. The height of the cone is 12 centimeters and the base of the cone has a diameter of 18. Work out the total surface area of the cone and give your answer in terms of pi. To begin with, we need to find out L, because if we look at the top, curved surface area of a cone is the equation of pi RL. However, we have not been given L, so we need to work it out. And we can work it out by using Pythagoras, as we said before. If we use R and make a right angle triangle using the H, we can use that to work out the hypotenuse of L. So obviously, we're going to have A squared plus B squared equals our L squared. And then 9 squared plus 12 squared equaling that. Obviously, that's going to sum to 225 equals L squared, meaning 15 equals L. Now, as we want the total surface area, we need to include the circle at the bottom. And we can quickly work that out because pi r squared, we can get it to 81 pi. Now we want the curved surface area of the cone, and that's pi times 9 times 15, which gets us to 135. Then we do 81 pi plus 135 pi to get our total surface area. It gives us 216 pi, and that's our final answer in terms of pi. Here's another exam question for you to have a go at. Have a go, pause the video, and unpause when you've done. Make sure you use the calculator for this one. So, a rectangle container is 12 centimeters long, 11 centimeters wide, and 10 centimeters high. The container is filled with water to a depth of 8 centimeters. A metal sphere of a radius of 3.5 is placed in the water, and it sinks to the bottom. Calculate the rise in the water level, and give your answer correct to 3 significant. Basically, what's gone on here is, we have a water level, what goes up to 8 centimeters. And we've placed the ball in the water, and the water has risen, obviously, because it has displaced. And it's now risen to a new high. If we work out this new high, minus it from the 8, we can work out the rise in the water level. So, to begin with, let's work out the volume of our metal sphere. So we do volume, 4/3 of pi, times 3.5 cubed, and we get 343 thirds of pi centimeters cubed. We then do the volume up to the water level, what it was before, 12 times 11 times 8, and that gets us to 1056 centimeters cubed. We now add the volume of the water and the metal ball, and this gets us to 1235.59. This total volume is also the same as 12 times 11 times h, which is our new height. And if we rearrange, we can find h. So we do h equals our total volume divided by 12 times 11, and we get 9.36. Now 9.36 is our new height from our 8. So if we do 9.36 minus 8, we can work out the rise in the water level, which is 1.36. So the rise in our water level, so 3 significant figures, is 1.36. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I'll see you in the next one. Goodbye.